June 6, 1944, 5:47 a.m., English Channel, 4 miles off Omaha Beach. The water was grey and cold and violent. Waves crested at 4 feet, sometimes 5, rolling across the English Channel with the kind of chaotic energy that made seasoned sailors, nervous and tank crews, men trained for land warfare, for the solid earth beneath steel treads, absolutely terrified. Inside landing craft tank number 7113, 5 DD tanks sat in darkness, their engines rumbling, their crews sealed inside hulls that would soon be submerged in seawater that could kill them in minutes if anything went wrong. DD stood for Duplex Drive, but the crews had other names for these strange hybrid vehicles. Donald Ducks, because of the initials; swimming tanks, because of what they were about to attempt; floating coffins, because of what would happen if the canvas flotation screens failed, or a wave broke over the fragile superstructure that was the only thing keeping 30 tons of steel from plunging to the channel bottom. Sergeant Robert Bob Simpson, gunner in the lead tank, could hear nothing but the diesel engine and the pounding of his own heart. He had trained for this moment for 8 months. Had practiced launching these tanks from landing craft in calm English bays, had studied the mechanics of the flotation system until he could assemble it blindfolded. But no training had prepared him for launching into seas like this, into waves that would swamp smaller boats, into water that looked like it wanted to kill anything foolish enough to enter it. Through the narrow vision slit, he could see other landing craft in the pre-dawn gloom, dozens of them, hundreds maybe, all converging on the Normandy coast. And he knew that in minutes his tank would drive off the ramp into 12 feet of water, would sink unless the canvas screens held, would swim, actually swim, toward a beach 4 miles distant, where German artillery and machine guns waited to destroy anything that emerged from the sea. The DD tank represented something extraordinary in the history of military technology. American engineering adapting British innovation to solve a specific, deadly problem. How do you get armor onto a beach when the enemy controls every approach? When landing craft cannot reach shore without exposing themselves to devastating fire, when tanks delivered directly to the beach arrived too late to support the infantry making the initial assault? The answer, developed through collaboration between British inventors and American industrial capacity, was to make the tanks swim, to transform them into amphibious vehicles that could launch thousands of yards offshore, could navigate under their own power to the beach, could arrive alongside or even ahead of the infantry, providing the armored support that meant the difference between successful landing and slaughter on the waterline. This transformation, from land vehicle to swimming vessel and back again, embodied American military philosophy in the Second World War. Innovation through engineering, problems solved through technology and industrial application, acceptance of unconventional solutions if they worked in practice, regardless of how strange they seemed in theory. The DD tank was ungainly, improbable, vulnerable in ways that made tank crews deeply uncomfortable. But it worked when conditions allowed, and on D-Day it would help establish the foothold on the European continent that would lead, 11 months later, to Germany's surrender. But to understand why the DD tank mattered, why it represented a capability that Germany could not replicate despite superior armored warfare doctrine and more advanced tank designs, one must understand the specific challenge of amphibious assault, the technological solutions that different nations developed or failed to develop, and the broader gulf between American and German approaches to military innovation in the war's later years. Amphibious assault against defended beaches ranks among the most difficult operations in warfare. The attacking force must transition from sea to land while completely exposed, with no cover, advancing against defenders who hold every advantage of position and preparation. Soldiers landing from boats are vulnerable, disorganized, often seasick, struggling through surf and sand while carrying heavy equipment. Artillery and machine guns can create killing zones on beaches that turn assaults into massacres. The historical, Record of amphibious operations is filled with disasters. Gallipoli in World War I, Dieppe in 1942, where defenders simply slaughtered attackers who could not get off the beaches, who had no protection, who were pinned down by fire they could not suppress or escape. The solution was armor. Tanks could provide mobile protection, could suppress defensive positions, could break through obstacles that would stop infantry. But getting tanks onto defended beaches presented its own set of almost insurmountable problems. Landing craft large enough to carry tanks had to get close to shore, had to lower ramps while under fire, had to expose themselves and their cargo to direct fire from beach defenses. Even if landing craft reached the beach, they often grounded in deep water, forcing tanks to drive through surf that could flood engines, disable weapons, trap crews inside steel boxes that became tombs if the vehicle stalled or was hit. Various nations attempted various solutions. The Germans, with their emphasis on armored warfare and their experience with combined arms operations, developed specialized swimming vehicles during their preparations for Operation Sea Lion, the planned invasion of Britain in 1940. These were modified Panzer III and Panzer IV tanks fitted with inflatable flotation collars and waterproofed hulls, designed to wade through shallow water or to be launched from landing craft in moderate depths. The prototypes worked in testing. They demonstrated that tanks could operate in water under controlled conditions, but the German swimming tanks had severe limitations. They could only operate in relatively calm water. They could not swim long distances. Their flotation systems were designed for wading and short-distance work, not for extended ocean navigation. They required calm seas and short distances from landing craft to beach. And critically, they were never mass-produced, never integrated into German operational doctrine, because Operation Sea Lion was cancelled and Germany's subsequent campaigns in Russia and the Mediterranean did not require amphibious assault capabilities against heavily defended beaches. The British and Americans, facing the opposite strategic necessity, they had to assault Fortress Europe from the sea, developed more capable swimming tank technologies. The British experimented with various flotation systems before settling on a design created by Nicholas Straussler, a Hungarian-born engineer. The Straussler system used a collapsible canvas screen that could be erected around a tank, creating a boat-like hull that displaced enough water to float the vehicle. A propeller attached to the tank's engine provided propulsion. The tank could be launched from landing craft in relatively deep water, could navigate under its own power for several thousand yards, and then could collapse the flotation screen once it reached shore, quickly transforming back into a conventional fighting vehicle. The Americans, initially skeptical of the swimming tank concept, eventually adopted it with modifications. American M4 Sherman tanks were fitted with the DD system in 1943 and 1944. The canvas flotation screens were made from rubberized canvas, supported by inflatable rubber tubes and a metal framework that could be collapsed hydraulically from inside the tank. The screens added about 3 feet of height to the tank's profile, creating a fragile-looking structure that seemed impossibly inadequate to keep 30 tons of steel afloat. But the physics worked. The screens displaced enough water to provide positive buoyancy. The tank sat low in the water, with only the flotation screen and the turret top visible above the surface, but it floated, and it could move at about 4 knots, using twin propellers connected to the tank's transmission. The DD Sherman was a compromise, like all military technology. It was vulnerable. A single artillery hit could rupture the screens, and the tank would sink in seconds. It could only operate in relatively calm seas. Waves above 4 feet would swamp it. The crew had to navigate using a compass and landmarks, limited visibility through narrow periscopes. If the tank sank, crew escape was difficult. They had emergency breathing apparatus and escape training. But getting out of a sinking tank in combat conditions was a low-probability survival scenario. Despite these limitations, The DD tank provided a capability that no other system offered, the ability to deliver armored firepower directly to a defended beach without requiring landing craft to approach within range of direct fire weapons. In ideal conditions, DD tanks could launch 4,000 yards offshore, over 2 miles, and swim to the beach, arriving before or alongside the infantry, immediately available to suppress defensive positions, to break through obstacles, to provide the armored support that transformed amphibious assaults from potential disasters into successful operations. The symbolic object that embodies this technological achievement is the canvas, flotation screen itself, that fragile fabric and rubber structure that kept 30 tons of American steel afloat, that represented the difference between swimming and drowning. That was simultaneously the key to the DD tank's capability and its greatest vulnerability. The canvas screen symbolized American willingness to accept imperfect solutions, to use available materials and proven technology rather than waiting for perfect systems, to deploy innovations that worked well enough under combat conditions, even if they appeared flimsy or inadequate to traditional military thinking. German tank crews, had they witnessed DD Sherman swimming ashore on D-Day, would have been baffled. German engineering philosophy emphasized robust construction, over-engineering to ensure performance under worst-case conditions, precision manufacturing that made systems as close to perfect as possible. The canvas flotation screen would have appeared to German engineers as absurdly inadequate. Fabric and rubber keeping a tank afloat? The idea violated principles of German technical excellence, suggested a casual attitude towards safety and capability that would never be acceptable in German military systems. But the canvas screen worked imperfectly, worked with significant loss rates in rough seas, worked with limitations that required careful judgment about when and where to employ DD tanks. But when conditions permitted their use, they worked well enough to provide the capability they were designed for, getting tanks onto beaches where they were desperately needed, where their presence meant the difference between success and catastrophic failure. The preparation for D-Day involved training hundreds of tank crews in DD operations. American armored units were withdrawn from combat in late 1943 and early 1944. Sent to England and put through intensive training in launching and operating DD tanks. The training was dangerous. Several tanks sank during exercises, drowning crews who could not escape. The men learned to navigate by compass from inside sealed tanks, to judge sea conditions from limited visibility through periscopes, to time the collapse of flotation screens so they could begin fighting immediately upon reaching shore. They practiced in English bays and channels, in conditions that were usually calmer than what they would face on D-Day, learning a kind of warfare that no American tanker had imagined they would need to master. Sergeant Simpson and his crew were part of this training cohort. They belonged to the 731st Tank Battalion, attached to the 1st Infantry Division, the Big Red One, which would assault Omaha Beach in the first wave. Simpson had joined the Army in 1941, had trained on tanks at Fort Knox, had expected to fight in deserts or forests or cities, anywhere except in the ocean. The DD training had seemed surreal at first, almost like a joke. Tanks that swim? It sounded like something from a comic book, not like serious military technology. But the training was deadly serious, and the exercises that went wrong, the tanks that sank, the crews that drowned, made it clear that this was among the most dangerous assignments in the armored force. By June 1944, Simpson and thousands of other DD tank crewmen were as ready as training could make them. They understood the systems, had practiced the procedures, knew the risks, and they were about to attempt the largest amphibious assault in history, landing on beaches that German forces had spent years fortifying, defended by troops who had every advantage except the one that mattered most. They did not know exactly where or when the assault would come. The German defenders at Normandy expected tanks, of course. They had prepared anti-tank obstacles, mined the beaches, positioned anti-tank guns and artillery to cover landing areas. Their defensive plans assumed that Allied tanks would arrive in landing craft that had to beach themselves, that would expose their cargoes while still in the surf, that could be destroyed before the tanks even reached dry land. The possibility that tanks might swim ashore from beyond the range of direct fire weapons was not seriously considered, not because German intelligence failed to detect DD tank training. They had some reports of unusual amphibious tanks, but because the concept seemed so improbable, so dependent on calm seas and perfect conditions, that it did not factor into defensive planning. This intelligence failure, this dismissal of DD tanks as too unlikely to matter, represented a broader German problem in the war's later years, the assumption that unconventional Allied technologies would not work under combat conditions, that German technical sophistication would prove superior to Allied improvisation, that quality would triumph over quantity and innovation. These assumptions, rooted in genuine German engineering excellence and early war successes, became increasingly detached from the realities of Allied technological development and industrial capacity. On the morning of June 6, 1944, in the pre-dawn darkness off Normandy, those assumptions would be tested against the reality of DD tanks swimming through rough Channel seas toward 5 landing beaches. At Omaha Beach, where Simpson's 741st Tank Battalion was assigned, the test went catastrophically wrong. The battalion's landing craft launched their DD tanks according to plan, lowering ramps 6,000 yards offshore, further than recommended, in seas that were rougher than safety margins allowed. 29 DD tanks drove into the water. The canvas screens erected properly, the propellers engaged. The tanks began swimming toward shore, and then, one by one, they sank. Waves broke over the low-profile flotation screens. Water poured in. The fabric tore, or the rubber tubes deflated, or the sheer violence of the sea simply overwhelmed the system's capacity. Tanks that had floated in training, that had worked in calmer waters, could not survive the channel conditions on D-Day morning. Of the 29 DD tanks launched from landing craft, 27 sank. Crews drowned, trapped inside as their vehicles plunged to the bottom in 12 feet of water, or struggled to escape through emergency hatches, weighted down by equipment, dragged under by the same waves that had swamped their tanks. 2 tanks reached the beach, 2 out of 29, arriving after the initial infantry waves had already landed, too late to provide the armored support that had been the entire purpose of the DD tank deployment. The disaster at Omaha Beach was not replicated at the other landing sites. At Utah Beach, DD tanks were launched closer to shore, in slightly calmer conditions, and most made it to the beach successfully, providing the expected armored support. At the British beaches, Gold, Juno, Sword, DD tanks and specialized British armored vehicles called Hobart's Funnies arrived in sufficient numbers to make significant differences in the assault's success. But at Omaha, the bloodiest of the D-Day beaches, the DD tank failure contributed to the near disaster that almost pushed the American assault back into the sea. The contrast between success and failure, often separated by a few hundred yards of distance or a few minutes of timing, illustrated the DD tank's fundamental nature. It was a high-risk, high-reward technology that worked under narrow conditions and failed catastrophically when those conditions were not met. This was not a flaw in American thinking, but an inevitable consequence of attempting something so inherently dangerous as making tanks swim. The British and Americans accepted these risks because the alternative, landing tanks directly on beaches in the first wave, was even more dangerous and had even lower success rates. German forces at Normandy, watching the assault develop, were overwhelmed by forces and firepower they could not counter. But the absence of swimming tanks in their own arsenal, the lack of any equivalent capability in German military technology, reflected strategic divergence. Germany in 1944 was fighting defensively, was not conducting amphibious assaults, did not need swimming tanks. But more fundamentally, German military culture in the war's later years had become rigid, focused on perfecting existing systems rather than developing radical innovations, constrained by resource shortages and Allied bombing that disrupted research and production. The DD tank, by contrast, represented Allied willingness to innovate continuously, to accept imperfect solutions, to deploy technologies that worked well enough under combat conditions, even if they were not optimal. This philosophy, good enough, fast enough, and deployed in sufficient numbers, characterized American military technology throughout the war. American weapons were often not the best in their class. German tanks were better armored and more heavily armed than Shermans. German machine guns were more effective than American equivalents. German artillery was often more accurate. But American systems were produced in quantities that made qualitative superiority irrelevant, were maintained by logistics systems that kept them operational, were crewed by soldiers who had been trained adequately, if not perfectly, and were supported by industrial capacity that could replace losses faster than combat could generate them. The DD tank embodied this philosophy perfectly. It was not an optimal solution to amphibious assault. An optimal solution would have been a fully amphibious tank, purpose-built for water operations, with sealed hulls and powerful propulsion and the ability to operate in any sea state. But developing such a vehicle would have taken years, would have required resources that were needed elsewhere, would have produced a specialized vehicle with limited utility beyond the specific circumstance of amphibious assault. The DD system, by contrast, converted existing Sherman tanks into swimming vehicles using relatively simple modifications. It could be applied to tanks that were already in production, already familiar to crews, already supported by existing logistics and maintenance systems. This was American military pragmatism at its finest. Identify the specific problem, develop a solution using available technology and materials. Deploy it quickly enough to matter in actual combat. Accept limitations and losses as inevitable costs of warfare. The canvas flotation screen, fragile and vulnerable, was not the perfect solution. But it was a solution that could be implemented immediately, that used proven Sherman tanks as platforms, that required training, but not wholesale reorganization of armored forces, that worked under conditions that could be controlled or selected by commanders making operational decisions. German military culture in the same period was moving in the opposite direction. Resources were being poured into superweapons, V-2 rockets, jet aircraft, advanced submarines that required enormous development time, that consumed resources desperately needed for conventional weapons, that produced minimal combat impact because they arrived too late or in too few numbers. German tank development focused on ever larger, ever heavier vehicles, the Tiger II, the Jag Tiger, massive machines that were formidable when they worked, but were mechanically unreliable, consumed scarce fuel, and could not be produced in sufficient quantities to affect the war's outcome. The contrast between DD, Sherman swimming ashore at Normandy, and German super-tanks that rarely left their production, facilities for lack of fuel or spare parts, illustrated the divergence between American and German military-industrial approaches. By 1944. America was producing adequate weapons in overwhelming quantities, using available resources efficiently, deploying technologies that worked well enough to accomplish their missions. Germany was pursuing technical perfection in systems that could never be produced in numbers sufficient to matter strategically, was fighting a war of excellence against a war of abundance, and was losing because abundance, properly applied, defeats excellence that cannot be replicated at scale. The canvas flotation screen, torn by waves and riddled by shrapnel on D-Day, represented the American philosophy made tangible. It was not excellent. It was not perfect. It was not what a German engineer would have designed if asked to create a swimming tank. But it was good enough, available immediately, producible in quantities that mattered, and it gave Allied forces capabilities that German forces could not match. Not because German engineering was inferior, but because German strategy and resources in 1944 could not support the kind of pragmatic, rapid innovation that American industrial capacity made possible. For the crews who operated DD tanks on D-Day, the experience was transformative, regardless of whether they succeeded or failed. Those who made it to shore, who collapsed their flotation screens and began engaging defensive positions, had accomplished something extraordinary. They had driven tanks through ocean surf, had arrived on enemy beaches under their own power, had been among the first armored vehicles to engage German forces in France. Those who sank, who drowned, or who barely escaped drowning, had attempted something that was inherently terrifying and had paid the price for operating at the edge of technological possibility. Sergeant Simpson was among the survivors. His tank was one of the two from the 741st Tank Battalion that reached Omaha Beach successfully. The journey through 4 miles of rough seas remains, in his later accounts, the most terrifying experience of his entire war. The tank rode low in the water, with waves constantly breaking over the flotation screen, with water sloshing inside the hull despite the waterproofing, with the certain knowledge that if anything went wrong, if a screen tore or a propeller failed, or a wave larger than the others swamped the tank, they would sink, would have perhaps 30 seconds to escape through hatches while wearing full combat gear and life vests that might not be sufficient in the violent surf. But his tank made it. The canvas screen held. The propellers kept turning. The navigation was accurate enough to bring them to the beach, roughly where they intended. And when they reached the shallows, when the tracks touched sand and the tank could begin to drive rather than swim, Simpson and his crew collapsed the flotation screen, brought the gun into action, and began engaging the German positions that were killing American infantry struggling to get off the beach. The impact of those 2 tanks and the handful of conventional Shermans that were landed directly on the beach by landing craft that survived German fire was significant but not decisive at Omaha. The beach assault teetered on the edge of failure for hours, with American infantry pinned down, unable to advance, taking horrific casualties from German machine guns and artillery. Naval gunfire and desperate individual courage eventually broke the deadlock. But the absence of the armored support that 27 sunken DD tanks should have provided made the battle far more costly than planned. At Utah Beach and the British sectors, where DD tanks and specialized armored vehicles arrived in greater numbers, the story was different. Armor-suppressed defensive positions provided cover for advancing infantry, broke through obstacles, allowed the assaults to succeed with fewer casualties and faster progress inland. The presence or absence of armored support in the initial waves, measured in dozens of tanks across several beaches, influenced casualty rates and territorial gains in ways that were quantifiable and significant. The post-battle analysis was honest and unflinching. The DD tank concept worked when sea conditions and launch distances were appropriate. It failed catastrophically when those conditions were not met. American and British military leadership did not abandon the DD tank after the mixed D-Day results. Instead, they refined employment doctrine, established clearer guidelines about when DD tanks should be used and when conventional landing methods were safer, continued to use DD tanks in subsequent amphibious operations in the Mediterranean and Pacific theaters where conditions permitted. This willingness to learn from failures, to adapt technology and tactics based on combat experience, to accept losses as inevitable in warfare while working to minimize them through improved procedures, characterized Allied military culture throughout the war. The DD tank was not perfect, had never been perfect, would never be perfect, but it was useful under specific circumstances, and those circumstances occurred often enough in amphibious warfare that the capability was worth maintaining despite the risks and the failures. German forces, meanwhile, never developed equivalent capabilities because they never needed them strategically, and because German military-industrial capacity by 1944 was focused on defense rather than innovation. The swimming panzers developed for Sea Lion remained prototypes, never mass-produced, never integrated into operational doctrine. When German forces needed to conduct amphibious operations, minor actions in the Baltic, evacuations across rivers and waterways, they used improvised methods or simply accepted the limitations of conventional landing craft and ferries. This asymmetry in capability mattered less for specific battles than for what it revealed about the broader strategic situation. America could develop, produce, and deploy specialized vehicles like the DD tank because American industrial capacity permitted experimentation and innovation, even while producing conventional weapons in vast quantities. Germany could not because German engineers lacked creativity or skill, but because German resources were stretched so thin that innovation became a luxury that could not be afforded. That any technology that was not immediately and obviously superior to existing systems could not justify the development costs or production resources. The canvas flotation screen, therefore, symbolized not just the specific technology of the DD tank, but the broader American ability to innovate continuously, to try new approaches, to accept failures as part of the learning process, to deploy imperfect solutions that worked well enough under combat conditions. This was not romantic or glorious. It was pragmatic, messy, often frustrating for the soldiers who had to use imperfect equipment under deadly conditions. But it worked in aggregate over time, across the full scope of the war. American forces had the tools they needed, even if those tools were not perfect, even if they sometimes failed catastrophically, even if they required courage and skill and luck to use successfully. The men who drowned in DD tanks at Omaha Beach paid the price for operating at this edge of technological possibility. Their deaths were not meaningless. Their sacrifice was part of the assault that succeeded despite the DD tank failures that established the foothold in Europe that would lead to Germany's defeat. But their deaths highlighted the costs of warfare that relies on innovative but imperfect technologies. The inevitable toll when soldiers are asked to use equipment that works most of the time, but fails catastrophically when conditions exceed design parameters. By late 1944 and into 1945, DD tanks continued to serve in various theaters, used in river crossings and smaller amphibious operations where their capabilities were valuable and where conditions could be controlled more carefully than on D-Day. The lessons learned from Normandy informed their employment, reduced loss rates, made the technology more reliable through small improvements to the flotation screens and launch procedures. The DD tank never became a dominant weapon system, never achieved the iconic status of conventional Shermans or other armored vehicles. But it remained useful, remained in service, represented a capability that existed in Allied arsenals, but not in German ones, adding to the cumulative advantages that made Allied victory inevitable. In May 1945, when Germany surrendered, American and British forces had conducted dozens of amphibious operations, large and small, across 2 theaters of war. The accumulated experience of these operations, the technologies and tactics developed to make amphibious assault possible against modern defenses, represented one of the great military achievements of the Second World War. The DD tank was a part of this achievement, one element among many that included specialized landing craft, naval gunfire support, air superiority, combat engineering, and ultimately the courage of infantry who had to cross the beaches under fire regardless of what support was or was not available. The canvas flotation screen, who torn and bullet-riddled, carried onto beaches across Europe and the Pacific, became a symbol of this larger achievement. It represented innovation in service of operational necessity, pragmatic engineering solving specific problems, American industrial capacity turning British inventions into mass-produced reality. and the willingness of soldiers to operate equipment that was inherently dangerous because the mission required it, and there was no better alternative available. German panzers, superior in many respects to American Shermans, could not swim. They could not approach defended beaches from beyond the range of direct fire weapons. They required conventional landing methods that exposed them to defensive fire at their most vulnerable moments. This limitation did not matter for German defensive operations in 1944 and 1945. But it illustrated the strategic divergence between a nation fighting to project power across oceans and a nation fighting to defend territory it already controlled. The DD tank was a weapon of power projection, of offensive warfare, of the kind of global military operations that only America and Britain could conduct in the Second World War's later years. The symbolic meaning of the canvas screen extended beyond its immediate tactical utility. It represented the possibility of transformation, a tank that could become a boat and then become a tank again, shifting between domains, adapting to different environments, providing capabilities that seemed impossible but were simply difficult, dangerous, and dependent on favorable conditions. This transformation, from land vehicle to amphibious swimmer to armored fighter, mirrored America's own transformation during the war, from a nation unprepared for global conflict to a military superpower capable of projecting force across both Atlantic and Pacific, of conducting operations on a scale no nation had previously attempted, of innovating continuously to solve problems that had no historical precedent. The epilogue of the DD tank story unfolded in museums and memories, in the scattered survivors of D-Day who could describe what it was like to drive a tank into ocean surf, to navigate by compass through rough seas while sealed inside a steel hull, to collapse flotation screens under fire and begin fighting on a beach that was supposed to be secured but was still deadly with German defensive fire. Some DD tanks survived the war, were preserved, became exhibits that educated later generations about the technological innovations that made Allied victory possible. But most were destroyed in combat, abandoned when damaged, or scrapped after the war when their specialized capabilities were no longer needed. Sergeant Simpson survived the war, returned to civilian life, rarely spoke about his experiences except when directly asked. The memory of swimming a tank through the English Channel, of being among the first Americans to reach Omaha Beach, of fighting through the longest day remained with him always. In interviews conducted decades later, he described the DD tank with a mixture of respect and terror. Respect for the engineering achievement that made it possible, terror at the memory of how fragile the canvas screens had seemed, how easily his tank could have joined the 27 that sank. How close he came to drowning in 12 feet of water while wearing 50 pounds of equipment inside a steel coffin. But he also expressed pride. Pride in having been part of something extraordinary, in having used technology that gave American forces capabilities that enemies did not possess, in having succeeded at a mission that was designed to be at the edge of possibility. The DD tank was not perfect, but it was theirs. It was American ingenuity and British innovation combined. It was a solution to a problem that had to be solved if the war was to be won. This is the larger truth that the DD tank and its canvas flotation screen represent, that modern warfare requires continuous innovation, that perfect solutions are less valuable than good solutions deployed quickly, that abundance and pragmatism defeat excellence that cannot be produced at scale. The DD tank swam ashore on D-Day, while German panzers, technically superior in many respects, could not. Not because German engineering was inferior, but because German strategy and resources did not support developing equivalent capabilities. The canvas screen, fragile and imperfect, kept American tanks afloat long enough to reach hostile shores, to provide the armored support that made amphibious assaults succeed, to prove that transformation was possible, that vehicles designed for land could operate at sea, That conventional wisdom about what was possible could be challenged and overcome. That American capacity for innovation and adaptation was itself a weapon as powerful as any tank or ship or aircraft. The men who drowned when DD tanks sank paid the ultimate price for this innovation. Their sacrifice was part of the larger sacrifice that made victory possible, that established the Allied foothold in France, that began the liberation of Europe. They died using imperfect technology in pursuit of necessary objectives. Died because warfare at the edge of possibility is inherently deadly. Died so that others might reach the beach and succeed where they had failed, and the men who survived, who drove their DD tanks through impossible seas and reached hostile shores and fought through the longest day, carried forward the knowledge that they had done something extraordinary, had used American engineering and British ingenuity and personal courage to accomplish a mission that German forces could not replicate, not because Germans lacked courage or skill, but because the strategic and industrial foundations of their warfare had become rigid where America's remained adaptive, had become defensive where America's was offensive, had become focused on perfection where America's was focused on pragmatic solutions that worked well enough, fast enough, in sufficient numbers to win. The clicking sound of the flotation screen framework being erected, the canvas being raised, the rubber tubes being inflated, this was the sound of transformation, of tanks becoming boats, of American innovation applied to British invention, of soldiers preparing to attempt something that seemed impossible, but was merely terrifying and difficult and dependent on luck and skill and courage. That sound, heard by DD tank crews before every launch, was the sound of warfare evolving, of technology adapting, of the certainty that the mission would be attempted regardless of risk. Because the alternative, not attempting it, meant accepting defeat or accepting higher casualties among infantry who would assault beaches. Without armored support, this is why the DD tank mattered, why its canvas flotation screens represented more than just clever engineering, why the contrast between American swimming tanks and German panzers that could not swim illustrated broader truths about how different nations approached warfare in the Second World War's decisive years. It was not about any single technology or any single battle. It was about the capacity to innovate continuously, to accept imperfect solutions, to deploy new capabilities faster than enemies could counter them, to use industrial strength and engineering pragmatism as weapons that were as consequential as any gun or bomb. The DD tank swam ashore on D-Day, and in doing so, proved that transformation was possible, that the impossible was merely difficult, that American forces could do things that German forces could not. Not because of superior courage or even superior technology in abstract sense, but because of superior capacity to innovate, to produce, to deploy, to adapt, to accept losses and learn from failures and continue forward toward objectives that had to be achieved regardless of cost. This was American power in the Second World War. Not perfect, often wasteful, sometimes catastrophically unsuccessful, but ultimately overwhelming because it was sustained, adaptive, pragmatic, and built on industrial foundations that could support continuous innovation while simultaneously producing conventional weapons in quantities that made victory inevitable through sheer material superiority. The canvas flotation screen, keeping 30 tons of steel afloat in hostile seas, was the visible symbol of this power, fragile but effective, imperfect but sufficient, innovative and pragmatic, and ultimately successful in providing capabilities that changed battles and helped win wars.